Hello everyone, I am Sandrex Merchant Mangalino and I am going to discuss the different identification of fishing gears materials through burning test, solubility test, and melting point test. The first one is the burning test. This changes in the material when it is near the flame and after the removal from the flame are noted. For this test, only a clean flame and two forceps are needed. In addition, the best source of flame is a Bunsen's burner. Alternatively, alcohol lamp or even a cigarette lighter can be used. A piece of netting material is bought near the flame and then removed. The melting and burning patterns in the nature of the residue produced, if any, are observed. In the early days of the introduction of synthetic fibers into fishing, the burning test was very often used by fishermen, as it is the simplest test for distinguishing synthetic fibers from cotton. Vegetable fibers and most of the man-made fibers made of regenerated cellulose burn rapidly in the flame and continue burning after removed from the flame. They have an afterglow. The smell of smoke is similar to that of burning paper and the residue consists of a small amount of fine ash. The synthetic fibers, being thermoplastic, shrink and melt in the flame. The melting substances drips from the flame, mostly forming a bead or a hard irregular residue. In this table, we can see the different reaction of materials of the fishing gears in burning test. In flame, Pa 6.6 and Pa 6 melts and then burns with light flame, white smoke, drops of yellowish melting drip down. NPES melts and burns with light flame, sooty blackish smoke, drops of melting drip down. NPE shrinks, curls, melts and burns with light flame, drops of melting drop down. NPP shrinks, melts and burns with light flame, drops of melting drip down. And PVC shrinks rapidly and melts, does not burn, sooty, melts into a crumbling black substance. In saran, melts and burns with light flame, and PBAA shrinks, curls, and burns very rapidly with light flame. Then after leaving flame, and PA6.6 and PA6 stops burning if melting drops fall down small bead on the end of the sample. Hot melting bead may be stretched into fine thread. And PES stops burning if melting drops fall down small black bead on the end of the sample. Hot melting bead may be stretched into fine thread. In PE continues to burn rapidly, hot melting substance cannot be stretched. In PP continues to burn rapidly, hot melting substance may be stretched into fine thread. In PBC, hot melting substance cannot be stretched. In saran, stops burning immediately, hot melting substance may be stretched into fine thread. And PBAA continues to burn rapidly, melting substance cannot be stretched. Next is the residue. Hard round yellowish bead not crushable. Hard blackish bead not crushable. No melting bead like paraffin crushable. Hard round brown to blackish not crushable. Hard blackish crumbly irregular, no bead. Porous blackish irregular substance crushable, no bead. Hard brown to black irregular not crushable. And lastly is the smell of the smoke in the burning test of the materials. The smell of the smoke in burning test is celery-like fishy odor faintly like pyridine, oily soot odor faintly sweet similar to scaling wax aromatic, similar to burning asphalt like wax paraffin, similar to burning asphalt like wax or paraffin, sharp sweet sweetish sourish, sharp acrid, sharp sweet like chlorine. Through this table, it showcased the reaction to the burning test of the different synthetic fibers by which they can be identified. However, in practice, the differences are not always so clear as shown in the table. For an accurate identification, it is necessary to verify the result of the burning test by the solubility test and or the melting point test. Next is the solubility test. This relatively simple chemical test does not require any particular skill in chemistry or any equipment or complicated equipment. The requirement for the test are 25 ml test tubes, a heat source, reagents, hot plate or test tube, glass beakers that have a 50 to 100 ml in size, and lastly, glass stirring rods are used. The fibers of the sample to be tested should be loose or fusible. Therefore, the netting yarn is untwisted and the fibers are cut into pieces of about 1 centimeter in length. Coarse material, like split fibers and monofilaments, should be reduced to very small pieces. Small samples of the material and 10 to 15 ml of the solvent should be put into the test tube. Further direction for the application of the solubility test may be taken from table. The reagents quoted have been selected so that only one reaction needs to be observed. Example is soluble or not soluble. In this table, we can see the identification of synthetic fibers by solubility test. Polyamide or PA fibers are soluble in the reagents A and E. If it is desirable to separate the two types from one another, C can be used in which PA6 is soluble but not PA6.6. In polyester or PES fibers are not soluble in A, F, and G. Next is polyethylene or PE and polypropylene or PP fibers are not soluble in B and C. The polyvinyl chloride or PVC not after chlorinated CO3 in the table is the only synthetic fiber here mentioned which is soluble in reagent G at room temperature. Next is the saron or PBD may be identified by its solubility in F and C. And polyvinyl alcohol or PVAA after treated with formaldehyde C-note in the table insoluble in A but not in E, and the PE and PP cannot be distinguished from one another by a solubility test. The burning test shows some differences in the reaction of these two synthetics, but it is not always sufficient for identification. The most reliable method to distinguish PE from PP is to determine the melting point. And finally, the melting point test. The melting points of the thermoplastic synthetic fibers are significantly different. The melting point of a known net material is therefore a way reliable identification method. Unfortunately, the equipment needed is not quite simple. Although the actual test with suitable equipment is easy to perform, the melting point test is mentioned here mainly because it enables one in relatively simple manner to determine type of material.